I'm an old guy, really old. But, I walk around college campuses occasionally and I see these T-shirts that say, there is no planet B. What bullshit? Of course there's a planet B and C and D and F. So I'll give you the question now. What do we do with planet B when we find it? Okay, this is a picture taken almost 25 years ago. Me looking a lot younger and a colleague of mine, but there's also Arthur C. Clarke. And I went to visit him in Sri Lanka, and really I think that he epitomizes what we're trying to do, which is that space is about a continuous adventure, the human spirit in our expansion. It's not necessarily about making money or getting scientific knowledge or military power. So I kind of dedicate everything I'm doing to Sir Arthur. The breakthrough initiatives, which I'm not going to talk about other than by referencing what we're trying to do, was started in 2015, a privately funded effort to study life in the universe. Our principal sponsor is Yuri Milner, a former Russian. He's renounced his Russian citizenship and contributed $150 million to Ukrainian relief. And our chief scientist was Stephen Hawking. So dedicate really a lot of this to them. We have three initiatives, and I'm really going to put this in context of what I really want to talk about is the Alpha Centauri system, which is, when I was a kid, my mother gave me two books when I was about 6 that encouraged me to learn to read. One was called Planets. The other was called Stars, and I looked at the planets and said, this is a boring solar system. Just, no exciting aliens or anything. And the Stars one said, hey, there's other systems. I'm going to talk about the next nearest one, which I think is much more exciting than this one when we find out about it. But there are three questions. Is there intelligent life elsewhere? And of course, whenever I talk about this, I say, well, people ask, is there intelligent life here? And I say the further away you are from a national capital, the more likely to find it. Of course, is there any other life in the universe, and can we travel between the stars? Now, Andrew Simeon talked about this program earlier, so I won't get into detail. This is a $100 million effort to see if we can find intelligent signals. And I put this picture up because about 2.5 years ago, Andrew called me. It was on Halloween. And he said, I think we have a signal. So I opened a bottle of champagne. Glug, glug, glug. And I was about to get to the second one, and he called back and he says, now look, it's probably likely this is interference. So, and I said, well, look, the whole team needs to be very quiet until we figure this out. 3 days later, this showed up. But the interesting thing about the star was from Proxima Centauri, the very nearest star, the small star in the Alpha Centauri system, which we now know has several planets, at least 2 that are probably in the habitable zone. So it was very exciting. I won't go into the signal. This is the signal. But it's this yellow streak. This is what's called a waterfall plot in radio astronomy. It's frequency versus time versus the power. And so this streak is BLC1, Breakthrough Listen Candidate 1. We now believe almost assuredly, but not quite 100%, that this is interference, which it turns out that there is no place on the planet we can observe without interference. Although we did get papers in Nature Astronomy, which is really cool. It was an undergrad that was the lead author, and he's now going to graduate school. He got a lot of offers. The only place we know of is the far side of the moon to do observations. So we had a kickoff last week in Australia for a far side of the moon radio observatory that is shielded from terrestrial interference, if we can keep it that way. But this is a program. I'm happy to chat more about it. But let me talk about the Alpha Centauri system. There's 3 stars. 2 of them are sun-like. One's a little bigger, one's a little smaller. The system is a little older than our sun, maybe 5 billion years old. The 2 solar-type stars orbit around each other in about an 80-year period. If we were orbiting Alpha Centauri A here, it's also known as Rigel Kentaurus. Alpha Centauri B would be about between the orbit of Saturn and Uranus. It would be very bright, but wouldn't put out much heat. Proxima Centauri is a red dwarf, about 1/10 the mass of the sun, really distant, about 10,000 astronomical units. But we started the announcement that there were planets orbiting Proxima Centauri was made in 2016. The European Southern Observatory was nice enough to invite us to the press conference, and we were nice enough to give them $5 million to go look at Alpha Centauri A and B. We do have a mission I'll mention here that we just kicked off. It's a small satellite in Australia. Actually, the satellite bus is being built in Bulgaria, but it's going to measure the precise position of one star relative to the other to determine if there's by the wobble of their orbits, if there's a planet. Now, this is a picture of artist's conception of what it might look like on the surface of Proxima B. When I showed this to our sponsor, he said, well, we don't need to go there, I guess. We know what it looks like. So careful when you show billionaires things. But at any rate, we had 100 hours of time on the Very Large Telescope in Chile. And by the way, astronomers are terrible, although I am one, in names. This is the Very Large Telescope, 4 8-meter telescopes. They're building a bigger one, a 39-meter, which is being called the Extremely Large Telescope. And no shit, when they started it, it was going to be about twice that size, and it was going to be called the Overwhelmingly Large Telescope. Come on, we can do better than that. At any rate, from this data, we have a 3 sigma result. There's a planet orbiting Alpha Centauri A in the habitable zone. It's a giant planet. And it turns out this is exactly the scenario in Avatar. And so we got a hold of James Cameron. He's quite excited. We're hoping to get money out of him. But the giant planet called Polyphemus is got moons, one of which is not only inhabited, or habitable, but inhabited, which is sort of the question there. Can we go there? So our third program was called Breakthrough Starshot, started in 2016. This was the announcement in New York at the New World Trade Center with actually a number of, there's Milner and Hawking, but also Freeman Dyson, Andrewian, Avi Loeb, Mae Jemison, and this geeky guy you're seeing today. But when we started looking at how do we get to Alpha Centauri, it's like effing hard. But the method we sort of looked at as an old idea, which is Kepler said something to Galileo that we'll sail in heavenly winds. And so we're going to assume that what he was talking about was light. So we're looking at light sails that will be driven by a very high power laser. When I say high power, 100 gigawatts. The spacecraft's a few grams, and the sails of maybe 5 or 10 meters. And of course, light sails work. This was the first light sail that was shown by the Planetary Society, a privately funded effort over a decade ago. The laser is like really effing big, kilometers in diameter. If we're going to Alpha Centauri, which is 61 degrees south declination, you need to be in the southern hemisphere. And so when people ask where we would put this, at the press conference, I said, in Chile, in the Atacama Desert. Now, I neglected to tell the Chilean government. I've since been summoned to talk to 2 presidents of Chile. The new president also wants to talk to me. They said, we're happy to help, but please tell us in the future when you want to put giant lasers in our country. But this is an artist's conception. You would fire this thing for about an hour. These would be held on a mothership. There would be hundreds, if not thousands of them, that could be accelerated to 20% light speed with a few tens of thousands of G's acceleration. So it's kind of like the gun launch, but goes on for a little longer. But some 25 years later, we would fly by Alpha Centauri and send the data back. So I think we're going to find a lot of planets there. We have some other programs that I won't get into, but I think we'll find Planet B probably in the Alpha Centauri system. And it's kind of an interesting thing in nature that the solar-type stars are only about maybe a quarter of them or less, that the nearest star system has 2 of them. And so I think we're going to find it's much more interesting than this system. And so the question there is, what do we do with it? Do we settle it? What if it has life already? Do we put life there? But that's one of the interesting questions for this group. Thank you. Bob?
Yeah. Well, I've brought this up to you before, but I'm going to bring it up to everyone so you can be embarrassed. Okay, if you look at the Breakthrough Starshot, okay, the sail is immediately doable, more or less. The micro spacecraft is immediately doable. The part that's not doable in any time soon is the giant laser.
Actually, you're wrong.
Well, slow down.
There's been major breakthroughs in to do photonic lasers, and that we think that if we did it today with using diode lasers, it would cost hundreds of billions of dollars. But we had a breakthrough that the Australian National University made, that we can phase things over kilometers. And
I'm not talking about a technical in principle. I'm talking about actually doing it. And what I'm saying is, if you simply use the micro spacecraft and the sail, you could do something that you could get to 1% the speed of light.
Oh, yeah.
And you could get to Saturn in a couple of weeks. And this would be a hell of a demonstration.
Actually, I've been in violent agreement with you. We've been pushing that with our sponsors. If you do sun diving, you can get even higher speeds. So I'm quite excited about that. So we're hoping that we've just finished our first phase of the program, and we're proposing, what do we do? I do want to do, near stuff, fly to the outer solar system, look for life, fly to near interstellar space, and that's the sun can do that. So you're absolutely right. So we listen, but we're also going to do the interstellar stuff a few decades later.
Wonderful. We have another question here.
As Edward Teller says, we're in violent agreement. Yeah.
How do you deal with the challenge of it essentially being a very large anti-satellite weapon?
Well, that's first of all, the where we would build this, it would be at a fixed elevation, so that you don't have an infinite area. Second, you'd probably have some international agreement on how we'd handle this consortium. Finally, if we really wanted to do this in a big way, we'd put it on the far side of the moon.
Yeah.
Or you could just shoot down all the enemy satellites.
Now, I was a general in the Air Force, so I don't mind that either.
I don't know who was first here, but
I can't help wondering what we would think if we had thousands of these probes coming through our solar system from Alpha Centauri.
Well, it'd be kind of cool, but
We might be a little worried.
well, we'd fire back. It turns out the amount of energy in even a few gram thing is a small nuclear weapon.
Oh yeah.
But I don't think we could see them with our current technology, because they
Tiny, but they do have big sails.
yeah, but it's 5 meters,
Yeah.
and so they're gone in a few hours.
Does it jettison the sail once it's
No.
reached acceleration?
Well, there's actually no way to break it. Well, there is if you go slower. I mean, this is a long. Yeah. No. I mean, the point is that we probably wouldn't go that close to the planet. We probably, if you're too close, you get by too fast. Now you got to track it. At 20% light speed, we'd probably be, 500ths of an AU that we'd fly by. So you wouldn't see them most likely unless they hit. If they hit the atmosphere, it would look like a meteorite, a big meteorite.
How do you get a signal back?
What?
How do you get a signal back from such?
You have a laser on a transmitter on the sail. The sail has actually come along quite well. Harry Atwater, who's the head of engineering at Caltech, leads our effort, and it would be integrated in the sail, so it's as with the chip, but you actually would use a sort of a kind of a geometry and photonic emitters. So you would focus, you'd use about a meter of the sail to focus something like arc second on the position of the Earth, and we think we can hold it that, because you point where the Earth's going to be, but you have the sun is one of the brightest stars in the sky, so you just lock on it.
Sure.
And
you have to have a huge aperture receiving that.
actually, we went through that. It's about a couple hundred square meters, and the technology to build light buckets that size is there.
So are we talking about a formation flying of these?
No, we'd launch one every few days.
and those will not be connected. Like it will
They're
not
not
be
gonna be
like.
connected. I mean, I can talk about it where you would daisy chain them.
Yes.
But the trouble is that how do you aim where the other one is? And when I was a kid in the 50s, a long damn time ago, we used to have holiday lights that were wired in series, and so every year about 2/3 of the damn strings didn't work. And so it was my job as a kid was to get them out, and so the 2 or 3 that worked, my mother would have those because she didn't want me to fiddle with the electrical outlets. And so then she'd plug one of those in, and so you would go through and change each one of them, and then about another half of them worked, and then you would change all of them, maybe another few of them would work, but then the rest of them you just threw out. So we're going to lose quite a few to interstellar dust and other things. So so I think the idea that you could, because if you miss one of them, you're out of luck. Anyhow, sorry.
Well, we have one more quiz.
I just wanted to say that it's an interesting idea for a techno signature, which is meteors coming in at regular intervals.
Well, since you mentioned that, Professor Loeb, who chairs our advisory panel, thinks that Oumuamua was a laser-driven light sail, or some sort of light sail, and he wrote a best-selling book, and he's has a foundation called the Galileo Foundation, I'm skeptical, which is I'm being nice, although it's a clever thing. So his argument is that first interstellar meteorite, because it showed a small acceleration, which can easily be explained with other ways. I'm told that it was a potential light sail. So.
Avi is also coming to our Vision Weekend this year.
No, I mean, he's a really, really bright, cool guy. I mean, he's a theorist, so he's likely speculative. So, all right.
Thank you, Pete.
Thanks.